Welcome, everyone. Great to be with you today virtually. Like I said, I was saying, I miss the days when we actually could do these kinds of conferences in person. You probably do too, for those of you who would be close enough to attend. Todd and the folks at All Things Open and Open Source 101 do a fantastic job with putting these things together and getting together the speakers and the content for people who really want to learn. So always happy to be a part of it. My name is Brent Laster, and I'm going to be talking to you today about Helm and Kustomize, how we orchestrate some stuff around Kubernetes. Really quickly about me, my day job is an R&D director at SAS, software company here in Cary, North Carolina, where I'm based. Shout out to SAS for always supporting us doing these kinds of presentations and sharing back with the open source community here. Do a lot of global training too, in addition to that. A couple of author books and things they've written. Information at the bottom here if you're interested in connecting with me on social media. When I do other training courses, I try to put it on Twitter, so feel free to reach out there if you want to. Really quickly, a couple of books if you're interested in learning more about Git. In the past, when we've done these kinds of things in person, we've given copies of these out. Unfortunately, we don't have this time, but if you want to learn more about Git, I'm a bit biased, but Professional Git is one of the books I've written. Another one is Jenkins 2, and this goes into CI/CD, pipelines as code and such. I will say, if you get this one, to maybe just check out the electronic version. The screenshots in the printed version are a little bit hard to see, more than a little bit in some cases. The printing just didn't work out. Electronic version should be fine. So if you're interested in learning about Git or Jenkins, check those out. Also, I do quite a bit of training for O'Reilly too. Just to mention, I don't mention that to put in a plug for my courses, but O'Reilly has a lot of courses out there as well, and do a lot of different things on there with Git, Kubernetes, pipeline, Jenkins 2, those kinds of things. So just if you're interested, search for my name out there and you'll find that. All right, enough about me. Let's talk about a couple of quick things here. I know if you are on this track, you've probably been through some of the other things with containers and Brad's talk on Kubernetes. So really quickly here, just do a really quick Kubernetes refresh because I never want to assume the point everybody's starting from. But if you're coming to this and you don't have a fundamental grounding in Kubernetes, very briefly, we'll just talk about what it is and kind of how ways to think about it. So in, the PR kind of form of this is Kubernetes is a portable, extensible platform for managing containerized workloads and services. Really what it's about, it's a way to run multiple containers and to automate them, keeping going, making sure they're always running, making sure they scale as they need to, ensuring that you're not having to sit there and monitor your containerized applications and workloads over and over again, and making sure, always watching them to see if they're okay or not. It's really about being able to run these large sets of containers, because as you probably gathered today, these days, when we're talking about running in the cloud, running in Kubernetes, we are talking about being able to spin up things on the fly with our application running in there. Container, as you probably gathered, is a simple little way of sort of isolating an application, isolating some of the resources on a operating system, and then giving an application the perspective that it's running within its own system, its own box. We take portions of the operating system resources, we carve them out, and we give that to a container. But most applications require more than just one container to run. You may have various microservices, databases, backends, front ends, and so on. So you really need something to help automate running all of those things so that your application is up and it can scale and it can keep going no matter what happens in an automated way. So Kubernetes makes that a lot easier and groups containers in this way with service on the front, so you can connect to things in your applications, deployments to make sure it's always up and running, those kinds of pieces. A robust platform for running containers. It really is about automating deployment, scaling, managing these workloads, and doing it in a resilient way. So it takes care of things like scaling requirements, failover, deployment patterns, all these kinds of things that you can imagine if you are supporting an application. you want these things to be handled for you, especially if it's running in the cloud. One of the examples we talk about with scaling up and scaling down, raising containers, is like if you're a retail establishment and you get to the holiday season and you need to scale up your number of containers that you're running to handle the workload. You may have a front end piece, you may have multiples of those pods in Kubernetes to be able to handle the load. And then later on, you need to be able to scale it down after the holiday season so that you're not incurring the cloud costs. Those kind of operations, being able to quickly spin up more and resiliently scale them up, scale them down. That's why we do containers in the first place, and that's why we have Kubernetes to help manage all these kinds of things out there for us. So how do we think about this? And I like to use analogies when I'm doing teaching. And one of the ways that I think about Kubernetes in terms of how it relates to containers is the same way that you might think about the same jobs that a data center would do. Everybody has probably seen a data center either at, you're going to school, with college, or about larger data centers that we have for Google and different around the country, or in any kind of large business if they still do stuff on site. And if we think of images or containers as being like computers that we stage and use, one of the ways I tell people thinking about a container and the image that goes into it, we are layering on software, much like you might install a system for your friend or coworker at your work. You're putting on the software, putting all the operating system and the applications and stuff into that image on that system, and then you turn that system on, and you've got a running computer. Kind of the same idea with containers. So in a data center model, what data center does for containers is a couple of things. It thinks about the main jobs being to provide systems to service the needs. You have these systems that you set up to handle a particular application running, keep the systems up and running. If something goes down in there, there's a data center operator that actually takes care of making sure to go and check on that system and to replace it if needed, add more systems, remove systems depending on the load, that kind of scaling thing. If again, you get to the retail, if you're a retail establishment and you have your own data center, you might be adding more computers in the old way of doing this to handle the load. Same kind of idea with scaling in there. Deal with the systems that are having the problems, deploy new systems when needed, and simple access to pools of systems. So all of these things that we traditionally would do with actual computers, individual machines, or individual cards with CPUs and stuff on them in a data center, and we would have people doing those kinds of things. That's the same kind of thing that Kubernetes does for containers. Just to go over some quick terminology things again. When we talk about Kubernetes, we're talking about a Kubernetes cluster as being the set of machines that runs Kubernetes, the set of high availability computers. You have the Kubernetes master and then the worker nodes. And it can be virtual machines, it could be physical machines, but they're all coordinated to make up the set of machines that can run your containerized workloads. A pod is simply an object in Kubernetes that wraps around one or more containers and any kind of attached storage they have. So at the lowest level, Kubernetes is dealing with the idea of pods, but pods just encapsulate the containers. A service, a Kubernetes service, as opposed to a microservice, is simply a way to have this virtual address to be able to get to your pods, to be able to get to your application. And a deployment simply says, I want this kind of a pod spun up with this from this container, with this kind of storage or whatever the case may be there, these kind of ports open, whatever the case is. And then I want X number of them. And so it tells Kubernetes, I need always have 3 of these. So if one goes away, Kubernetes then has the job to say, whoops, you asked for 3 and you've got 2 running, I will spin up another one for you. So deployment says, how many of these do we have? Ingress is a simple resource that lets cluster applications be exposed to traffic, and then the namespace is a logical grouping of them. So just to kind of reiterate the sorts of objects we have to deal with in Kubernetes. So if you want to think about our data center analogy here, think about like a container being in a pod as being like the servers in a rack in the data center. If we think about a container being that self-contained environment there, much like we have a box or a system in the data center, which has a application and is set up to run for that, to support that. If we put a container being in there like a server in a rack, then we might say that a pod, which is a group of containers, or can be more containers, it could be just one, could be like a rack of servers, those whole systems that need to be in close proximity. They need to be able to easily talk to each other and share the same storage, maybe on the back end, those kinds of things. If we talk about deployment, we can think of that as being, how many of these racks do I need to service a load here? The service, a Kubernetes service, is a central control or access point. If you've ever logged into a set of systems and machines, you log in and then you get to a particular machine assigned to you to work with remotely. Same kind of idea. The service is sitting on the front end and can talk to different pods running your application on the back end. And then we might think of the namespace as being like the server room where all these things are grouped together. So that's just one way to think about it, kind of a very quick analogy, but sometimes I find that using these sorts of analogies is helpful to people to kind of wrap their head around some of these newer concepts that you may just be getting into. One of the key things about Kubernetes is that it is a desired state system. Simply means that we are supplying our desired state by generally passing it through what we call manifest. A manifest is nothing more than a YAML format. YAML is a type of scripting, stands for markup language, with a specific format. And we can describe the kinds of objects we want to Kubernetes, and we can hand them to Kubernetes. And Kubernetes has the task then of working to say, here's what you've asked me for. You've asked me for a pod that looks like this. You've asked me for a service that looks like whatever, and I'm going to ensure that you get that spun up. So Kubernetes' job then is to say, based on what you've asked for, then go ahead and spin that up in the cluster. Now, this is what we call a declarative way of doing things, as opposed to the imperative. Imperative and declarative, you'll hear those terms sometimes. And the way I typically tell people, one way to think about that, if you consider, that, and I use a little joke here, when you go to feed your family in the evening, or if you're feeding yourself, it's imperative that you have dinner. Imperative would be you're getting the recipe, you're getting the ingredients, you're going through and doing the steps to cook it all up yourself. And you are doing that so that you end up with what you've asked for, but you have had to either do it yourself or tell somebody, perhaps if you're, helping your kids cook or something, telling them exactly what they need to do. That's an imperative thing. Declarative would be when, the pandemic allows, you're able to go out to restaurants again, and you get a menu and you say, I want one of these and one of those, and I want something like this, looks like this. And you tell that to the waiter. And then you have given them your order, your desired set of things you want, and the waiter takes it back to the kitchen, and the kitchen crew will go through and prepare it and give you back the things that you've asked for. How many you've asked for, 2 of these or 1 of this or well done, however it is. So the declarative state is we declare to Kubernetes in these YAML files, this is what we want our service to be like. These are the ports we want open on our service. This is what our deployment should look like. We want a deployment that has running this container, using this image that we had, this Docker image to build a container out of, with things exposed there. And we need 2 or 3 or 4 of them, whatever the case may be. So we hand that to Kubernetes, and Kubernetes runs this, what we call reconciliation, to say, you've asked for this, I want to make sure you have this. And if at some point something crashes, something goes away, Kubernetes' job is to spin up another one to meet the desired state. So that desired state then is what we express in a YAML file in text generally. Now, of course, you can interact with a Kubernetes API. There are libraries and stuff. But in most cases, you're really talking about when you're having applications that you're deploying into Kubernetes, you have these sets of specs or these manifests. And I won't go through all of this now, but if you look at the screenshot on the right-hand side of this slide, you'll see that there is a specific kind of format here. For each kind of Kubernetes object, we get into talking about what API version is it using, which Kubernetes API version is supporting what we're asking for. The kind of object, is it a deployment? Is it a Kubernetes service? Is it just a pod definition or an ingress? There are lots of different kinds of Kubernetes objects. And then we get into things like name and namespace and so on. And then after that common, that sort of section at the top, is all common to any app object. You have to have the API and the kind and so on. Then the rest of this varies depending on the type of object you have in Kubernetes. For example, the spec, when we get down to the spec for the deployment at the top talks about how many of these do we want, how many replicas and so on, what kind of containers do we want to have, what images should they run. And then the service at the bottom has a different kind of spec. So we take these kinds of specifications, put them in this syntax, this format that Kubernetes is expecting, and then we can feed that to Kubernetes to spin up what we want. So that's a very sort of quick run through of Kubernetes to kind of get us to the point where we start talking about Helm. So what is Helm? Helm is kind of a package manager and lifecycle manager for Kubernetes. It's kind of like Yum or apt if you've used those other kinds of package managers on some of the Linux operating systems. And what it does is it takes these different kind of specifications that we would have for the objects in Kubernetes, the deployments, the service, the ingress, whatever, and for a particular, all the things that we need to run a particular product or application, it bundles them together into this thing called a chart. So Helm helps us to keep track of and manage and use and reuse these specifications that we're putting into Kubernetes. When installing chart, Helm creates a release. That is, we take the chart, the set of those specifications, we hand them to Kubernetes, and Kubernetes then with Helm spins up what we call a release. A release is an instance of all of those charts, so whatever's in the chart, all of those things spun up into Kubernetes, and we can treat it as a unit, okay? You'll see more what I mean in a moment. We'll go through a couple of animations here to help you understand it. Helm is about lifecycle management, doing things like being able to create, install, upgrade, rollback, delete, status, and versioning at the application or the product level. So rather than always having to keep track of every little detail and having to make sure that I upgrade the service and I upgrade the deployment and I upgrade the ingress, if that's the case, I can use Helm to batch those up or to manage those for me. So the benefits that we get from this, the benefits that we get are things like templating, repeatability, reliability, ease of collaboration. We'll talk about templating, but one of the other features of Helm is that it allows us to put placeholders in these files and to substitute values in for it. So we can reuse these things. We can make them reusable and be able to have placeholders in them so you could use them and run the application on port 30,000, and I could use it and run the application on port 30,001. We're still using the same files, we're just supplying different values to them. So why do we need something like this? We've alluded to it already, but really, when you start talking about all of the different containers you can have and all of the different applications or pods and deployments and such you can have to have an application in Kubernetes, it can get really out of hand really quick. For example, if we have a simple microservice, set of microservices here, one microservice to handle the front end of our application, one to handle the back end processing, one to handle the database. Each one of those, to make it run in Kubernetes, would need a deployment. They might need a config map. Config map is a way to sort of set values, kind of like you would do with environment variables, kinds of things, setting and storing values, configuration, ingresses, secrets, services, and so on. So these kinds of things will come in, and you might have a bunch of these. And by the way, I apologize, I should have said up front, we have quite a bit of material to cover, so I'll make sure to try to get to some questions at the end, but I'm going to try not necessarily to try to answer questions right now because there's a lot of material to cover. I want to make sure we get that. And sometimes I think if you, as we go through the process, go through the slides, a lot of the answers will come in the presentation as we go along. But certainly if you have questions, I'll try to make sure I cover some of those at the end of the presentation. So if we have a bunch of these microservices running and they all need these kinds of specs to tell Kubernetes how to spin them up and how to work with them and what ports are open, you can see we can start to get into some really lot of Kubernetes operations. Typically, we take a YAML file and we do a kubectl or a Kubernetes command line, kubectl apply to get these into Kubernetes. So we would do an apply. Now you can apply at a directory level, so you can simplify this somewhat, but still, if you get something, even a basic application might have, 10 different microservices or something that you're working on, depending on what it is. So it can get very complicated very quickly. In traditional Kubernetes, if we did a kubectl, if we had a deployment, a service, and an ingress for our particular microservice or whatever we're trying to run, we could do a deployment, we could do a service and an ingress, 3 separate applies, things that we're maintaining. If we needed to upgrade it, we go back and do those again, upgrade each file in there too. When we talk about using Helm, we have these applications, or these pieces rather, put into a single entity called a chart. A chart is the way that Helm groups these things together. And we'll talk more about the structure of that. But really what you have is the deployment, the service, and the ingress become these, look like a lot like the YAML charts, the typical Kubernetes YAML files or manifests with placeholders in them, with placeholders to put values in. And you have your values then at the highest level that you want to be able to plug into that in this values YAML file. So what happens with a Helm chart is you have your templates. These are the Kubernetes manifests with the placeholders. You have then a values YAML file, or other ways you can specify the values. And if I do a Helm install, Helm will take the values from that, instantiate each of those templates to create something that Kubernetes can understand, and then install that into the cluster as what we call a release. So it's a simple one operation, and I get to manage the entire set of things that I need from a microservice as a group, as a unit with the chart there. What are the advantages of using Helm? Well, it saves having to deploy multiple individual manifests for multiple Kubernetes objects, as we've talked about. It allows for reuse via parameterizing. We're going to talk more about that in just a moment. It allows you to manage as releases of Helm packages. Helm packages are where we take these and we compress them and we can store them in a repository. One of the key things that Helm also provides is an easy way to install applications in Kubernetes. If you're looking for something, application that's going to run in Kubernetes that somebody else has created, they may have created a Helm chart for it. And that makes it very easy then to get the Helm package, that compressed version of the chart, out of a repository, a Helm repository, pull it down and do a Helm install into Kubernetes, and you're up and running very quickly, as opposed to having to do something like copying it out of all of the files for a deployment, a service, etc., out of like a GitHub project, and then going through and do kubectl applies and trying to make sure everything is in there that you need. Helm allows us to package those up, and it's become one of the common ways that people deliver software applications for Kubernetes through a Helm chart, these set of files that describe everything that needs to go into it, all the types of Kubernetes objects packaged up. So it makes it easier to share. When we talk about some of the terminology or topology of Helm, a chart is simply a bundle of these Kubernetes resources. A release then is these Kubernetes resources actually deployed or put into and started up in Kubernetes. The same chart can be installed several times in the same cluster with its own release. A repository, in terms of Helm, is a repository of charts. So I take my application, I would take, like if I create a service and a deployment spec in there, and I could package those up with Helm, and then I could share them out with other people. I could package them up as a Helm package. Somebody else could then take my Helm package from the repository and get it as a chart and then install it into their Kubernetes. And a template is simply a Kubernetes configuration file with some templating. We talk about Go and Sprig. Probably everybody's heard of the Go programming language. Sprig is a set of templates. These are things that allow you to do things in there, to have placeholders to put things in, as well as functions that can do things like uppercase something or put quotes around something, since we're dealing with YAML. What you see on the screen here is one of the things I use in some of the classes I teach. You can see there's a product called Istio, and then there's a Jenkins X, and a couple of other things here. which are actually installed and running in the cluster as these Helm releases. There was a Helm chart that specified all the things that were needed for Istio or for Jenkins X, and it's deployed in there. And so and this is the version of the chart being that collection of files. And then you can update these, you can roll them back and so on. So let's talk a little bit more about what a chart is in Helm. A chart is simply a packaging format for Helm. By the way, I do realize we are going through a lot of content here. Again, 45 minutes in this kind of environment. It's really about exposing you to the content to give you the big ideas in there. Certainly don't feel overwhelmed by it, or that you're not grasping everything. It's not in the time frame we have. That's challenging to do, but I want to at least expose you to the ideas, kind of give you an idea of how things are work. So if you're interested, you can go up then and explore other kinds of information about it. So a chart in Helm is simply a packaging format for all of the things that we're going to need to have running in Kubernetes for our application. It is a deployable unit. That is, it is something that we can treat as, say, deploy this into Kubernetes. Regardless of what's in the chart, Helm, go install this, and then expect it to be up and running. It is a way of kind of having like our source code for our specification going to Kubernetes. We can track these, we version them. You can have versions of charts and versions of even different versions of charts relate to different versions of your application. And charts can also include other charts as dependencies. So to give you a quick idea of what's in a Helm chart here, typically you would have a chart that is a directory. You would have a chart.yaml. Chart.yaml is simply this high-level description of a chart. Might have things like the name in there. It could also have listings of dependencies, other charts in there, and specifications about what versions of Kubernetes it would be compatible with, those kinds of things. There's a values.yaml file. The values.yaml file is where we can separate out the default values. We can say these are the default values that you plug into those placeholders in the files to be able to actually get then the rendered things for Kubernetes that work with that. So this is a set of default values, but this is also a place where someone else who needs to have a different value can go and simply update their copy of the values YAML file and then run the application with their settings. So instead of having to go into each of the files, deployment, service, or whatever, and make copies of that, and then hard code values in there in that way, I simply can change the values in the values YAML file. That's how we promote reuse with this. If I didn't do something like Helm, I would have to go in and make a copy of somebody else's chart or somebody else's files, like the deployments YAML, the service YAML, and so on. Hard code values, keep that somewhere. Worry about if the if somebody made changes to the other one, get a new copy and hard code it. Whereas with this, I can simply just replace the default values with the values I want. You can also supply values from the command line to override it as well. Then we have a template subdirectory. And this is where we put those files that look very much like standard Kubernetes manifest, but with the placeholders in them where values can be plugged in. Here's an example of the chart.yaml. As I said, basically just some very simple case here. The API version, the description, the name, the version of the chart, and so on. Values YAML, you can see this is a YAML format, and YAML, again, if you're not familiar with that, is a way of structuring data. And the idea with YAML, the key thing to know about YAML is that the indentation matters, the white space there, because the top level things that are indented under that belong to the thing above, and things that are indented to that belong to that thing, and so on. So the indentation represents effectively like a hierarchy that you're going to go through to get the value. So for example, here, if you look at line 8, this is saying that our deployment, for our deployment spec for Kubernetes, the ports area, we have a port named MySQL there. And so that's on 3306. Or we have an environment variable down on line 10 that are defined for our Kubernetes deployment. And you can see at the bottom, then we have, starting at line 15, things that are default values for the service. So again, instead of having to go into those things in hard code files, we can extract them out and put them into the values YAML. When we get to this helper TPL file very quickly, this looks really kind of a funky syntax. It's really a way of actually writing helper functions. And it won't go into it here, but essentially it is a way of writing little routines or little processes to say, if I give you information, give me it back in this form. Maybe I say, what's the long name of the chart or the short name? Or maybe I do some basic addition. Maybe I expect you to go through and say, if I give you a value here for a port, add 1 to it so I can pass that back to something else. That kind of thing. You can write helper functions in there. Then the service YAML, this looks a lot like a standard Kubernetes service if you've seen any of those today or if you worked with Kubernetes. Again, at the top, you'll see things that look much like we did in that one slide. We have the API version for Kubernetes. We have the kind of object. We have metadata, name, labels, and so on. But then you see these kind of funny characters on here that look like these double open braces and double closing braces. What this is these are placeholders. This is where values will be filled in at the time you do an install or an update or something. Values can come either from running template functions, like functions help defined in the helpers TPL, or values can come from this values file. When you see .values, it means get the values out of the values file, or they can be built in like a release name and such. So any place that you see these kind of double braces opening and closing, that's a place that we are putting in a placeholder, and we are saying, this is how you find the value we want to use for this. Go to the values file, go to the service section, go to find the port name. And the same thing for a deployment, same sort of idea. It's a standard sort of structure for a Kubernetes manifest, but it is simply just with placeholders in there. So a chart repository, that's what a chart is like. A chart is that collection of templates and values and data there. A chart repository is a Helm repository. In other words, we can just very quickly here, we can have different places where we package up these charts and we actually then store them in the repository, and then other people can get to them. And Helm allows you to actually add charts and references to them. So we might have a stable chart which goes out to one of the places where Google stores some charts. We might also have a local place here where we have a local place on your own machine, for example, or even a company within your company. You might have your own Helm chart where you package up applications and make them available for other people to consume. If you're wondering how that works, very quickly, we'll just show you. Normally, if I have an application that I've developed for Kubernetes, when I'm ready to put it into Helm, I can simply take it and turn it into a chart, which means I extract values out, I templatize that, or you might start with an existing chart and modify it for your needs. I can then use the Helm package command, and it compresses it into this single compressed file that we can store in a Helm chart repo. And a Helm repo, there are all kinds of things. There's one called Chart Museum, which is a very simple one to do. GitHub has its own place where you can store charts. There are other ones out there. There used to be a Helm Hub, a main one, but they got kind of tired of trying to manage that and compare it all. So now they've kind of gone and said, everybody do your own repos out there. There are still some larger central ones, but that package then can be packaged up and put into a Helm repository. Somebody else then could take that package, do a Helm pull, or otherwise get it out of there. You can also just do like a curl command and do an install, and they could be running the applications in their Kubernetes system, and they have a release of the chart. Here's some chart repositories here. Some standard ones. There's a deprecation notice here where they deprecated the main one, but you can see there's Chart Museum here. There is an artifact hub out there. You can go find Helm charts out there. So you have lots of things. In Helm itself, you can connect up to a repo. You can add a repo and give it a reference name, like calling the stable points to this location. You can search repositories. You can add references to it. and so on, list out the repositories. So you connect up to repositories if you're going to get an existing Helm chart that's stored in that. Then you can grab that Helm chart, bring it down, and use Helm to install it into Kubernetes and get the different applications. Lots of Helm operations here. You can see, I won't go through all of these. Most common ones, you might install a chart, add repos, search, those kinds of things when you're starting out. But you can see you also have things like uninstall, upgrade or release, and so on. So to give you a visualization of this at a kind of a high level, imagine that we are working with Helm and we want to install a chart. So we have a Helm install of a chart with a particular name, say a name we're going to have for the release in there. Then the Helm command or the Helm's client talks to the Kubernetes API server. And what that does, it says, hey, take this chart and all the pieces in it, go ahead and get those up and running. So if the chart has a definition for a service, a deployment, an ingress, it starts it up and running. That becomes a release within Kubernetes. That becomes release 1. If I want to get information about releases, then I can do a Helm list, a Helm status, history, and so on. So some Helm commands work with charts and some work with releases. The release is simply an instance of the Helm chart running in Kubernetes. When we upgrade a chart, if I want to get, if I say I make a change to a chart, maybe I update a value, maybe I add a new piece to it, maybe I update a deployment. In that scenario, if I've still got release 1 running here in Kubernetes, and I say, I've got a new version of foo that I want to upgrade, I talk to the API server, and it goes through and maybe puts out a new version of the deployment there. So I get an automatic upgrade, and that becomes release 2 of foo. Before we had release 1, now we've done an upgrade, release 2. So you can start to see how the lifecycle pieces work, from installing to upgrading and so on. With rollback, I can even roll back. Let's say I tried release 2, it didn't do what I needed to, or it broke, there's a problem. I want to go back to what I had before. So I can say Helm roll back to release 1, roll back to the first release that I had in the Kubernetes system. Talks to the API server and says, okay, I'm putting deployment A back, which is what, now you're at release 1. All right, now you're at version 1 of that thing. But notice that it's at release 3. So even if you roll back to a previous set of content for your release that's installed in there, everybody's Helm chart, it still creates a new release version in Kubernetes. So we roll back to the one that was the original content, but it still created an updated set of things or updated release in Kubernetes. One more quick point that's worth mentioning. You may, this is what we were talking about so far, and the examples we've been using are talking about Helm 3. Helm 3 is the latest and greatest. You may still encounter an older version of Helm called Helm 2. Helm 2 relied on, had some problems, put it plain and simple. And it had a lot of bad press, primarily because it actually required us to have a thing called tiller running in the Kubernetes cluster. And tiller was sort of the server side of Helm. And so instead of just talking to the API server, when we did a Helm install with version 2, it would talk to tiller, tiller would talk to the API server. Now you might say, why is that problematic? The reason it was problematic was because tiller, this Helm was created at a time before Kubernetes was really locked down and had what we call RBAC, role-based access controls and permissions. And tiller was very hard when they started adding that to really lock it down, because it had to have permissions to do things to the API server and to make things happen. So it became really a sore spot with a lot of people. In version 3, they got rid of tiller and just started talking to the API server. But just FYI, if you do use version 2, some things are different about it. There'll be a tiller component and so on in there. Really quickly here, let's take a look at what a traditional Kubernetes YAML file versus a Helm template. So a lot of parts of this may look the same if we're looking at this. We may have the parts in yellow there, all just the same structure. We may then have additional things where we choose to take values that would normally be hard-coded, put them into a place where we can call a function to get a value, or we can get a value out of the values file there. We can get values out of that values YAML file, we can override it. So we can create these placeholders in there, and some things may be built in. That's what the green part is. So you can see it's basically, it's the same structure. It's just that when we take this Helm, we have the template, we fill it in with values, that becomes a file that we can actually use. To give you an idea of how values get resolved in Helm, when we have a values YAML file and a deployment YAML file here. Let's take a look at the deployment YAML. So let's take a look at this string. It says, in order to figure out what the container port is, use values deployment ports container port. So that says, go back to the values file, to what the .values at the start says, look up the deployment section, look up then the ports section under that, look up the container port, and then plug that in. So then when I actually render this, when I actually install it into Kubernetes, it comes out as this container port in here has that 3306 value. So you can see how it's actually resolved in there. Template functions, Kubernetes also, or Helm rather, also has functions that we can do. There's a set of like 60 functions that are provided, things like uppercase, quoting, even doing simple kinds of arithmetic. One of the examples I did when I was originally using Helm with Kubernetes, I had an application and I wanted it to be able, different people to be able to run it. But I didn't want to hard code a starting port. It needed a certain network port to be able to use. So I used a Helm chart, put a Helm chart in there and wrote a simple function that would always had an offset to it. So the different parts of it would start up. That way people could just supply a starting port on the Helm command line, and the function would add an offset to it and start up different applications. So as long as everybody used a different starting port, the rest of it was handled, just to give you an idea. So you can do some pretty sophisticated things with functions. Pipelines in Helm are not like CI/CD pipelines. It's the idea of stringing functions together. So quickly look at the bottom function here. You can see if I wanted to have a name value that I pulled out of there, I wanted to ensure that it was uppercase and it was quoted. I could say get the value from the values YAML file of user.name, uppercase it, and quote it, just passing it through there. All right, so reuse from customization. This is fine for a lot of use cases and it's been around for a long time. However, it does have certain drawbacks. When you talk about using Helm, you're really almost getting into kind of programming of things, and you're really getting into having divergence from the original source files, meaning I can't just take those Helm files and apply them. I have to do this through Helm. I have to actually use Helm to interact with Kubernetes, not just to render, and I can use there's a way just to render the files, but I can't take the files as they are. We're changing the original specs and then editing them. So this becomes a challenge. I mean, the other way to do reuse is to simply modify the original one. And I apologize, we're going to go a few minutes over here to talk about Kustomize really quickly. But but another way to do it is simply to say that we could copy files and we could actually go through and make copies of them, hard code them. Becomes hard to keep up to date and stuff. But the challenges with Helm, again, are that you have to understand the templating. It is more kind of like programming in some respects, depending on how complex you get. Many things become parameters for different users. Maybe I've got things in the values YAML file that are important to me. You come along and say, you know what, Brent, I need to add this, this, and this as a value in there. So eventually your values YAMLs can get pretty massive on their own. And it counters typical ghosts of reuse to keep differences between the specs small and simple. So another option for this is a tool called Kustomize. And what Kustomize with a K does is it's another way of creating specialized YAML files or manifests to feed into Kubernetes, but it takes a different approach. What Kustomize does is it takes a basic set of YAML files, and if you need to make changes, it creates other things that overlay parts of those or add on top of it. So there's a file typically called a customization.yaml file, which is a sort of a metadata file for Kustomize that says, grab these specs over here, these resources, these Kubernetes specifications, make some simple modifications, but not to the original file. Instead, produce a new file that is a result of the original ones plus the modifications. So rather than having to go and hard code placeholders and stuff in the original specs, what the approach that Kustomize takes is says, take the original files, let's then layer some other stuff on, and then I'll render a new version of the file with that in it. Let me give you the idea here. It's called the idea of transformers to be able to do that. As a very simple example, suppose that I have in my directory a deploy file, a service file, and a then customization YAML. And that customization, let's say a deployment file, looks like just a standard thing. These are files I could take and I could apply to Kubernetes as they are. I don't want to modify that. I still want to be able to use them that way. The customization YAML file then says, pull in, if you look at the bottom part here, the resources, pull in the deployment file and the service file, and then apply this thing called common labels. This is one of the customized features that says, I want to put a common label on these. So what happens then, I use the function called Kustomize build. Kustomize build says, take the original files, layer on any other changes that I've specified, and then produce an output that I can feed into Kubernetes. So it doesn't change the original files. Instead, what it does, it produces new files. It produces one, for example, if you look here, you'll see now that it's added in a label into the service definition for test and a label into the deployment definition for tests. So common labels. So you get the idea. The original files are still there. We're doing some modifications, but we are then producing a separate file through Kustomize build, and then we could take this file and just do a standard kubectl apply. So Kustomize doesn't manage releases and stuff for us in there, but if you are concerned or if you want to modify things without having to modify the original files and having to keep up with using templates and all kinds of things, it can be a good choice. Some common changes you can do, you can add a label, you can add an annotation, you can add a prefix. For example, here's a common annotation. Annotation just identifying information to an object. We have a customization YAML file here, which says, put these annotations, build, latest, and branch master onto this. If I do a customized build, I get an annotation, and I get a annotation there with that. And then we get the prefix here. It's similar, customized build in there. All right, so I think we are about out of time here, being told that we're out of time. Let's see. A couple other things about Kustomize, but we'll skip that for now. There is certainly more to tell about that. Kustomize, we call bases and overlays. Essentially, we have a set of bases, which are the core pieces as they are, and then overlays that we can apply on top of them. And we can do that at a directory level as well. So I won't get into all of that now for the sake of time. We can also do patches. We can patch things in there and update files that way. We can go back and find things in the original files, and then we can actually patch them up and produce output that way. So we have, again, the same idea. We're producing things in there. So I'm just going to quickly go through this. You get the idea. The customization YAML describes the kind of customizing we're doing to it. Then the customized build produces the file with that. Kustomize has a lot of features to it, different things you can do, and it's also built into Kubernetes, at least some of it, not always the most recent version. So that's it for Helm and Kustomize. I apologize, I ran a little bit short on time there, but I hope you get the basic idea. When you start working with Kubernetes, you get into this situation where you have a lot of things you're trying to manage with, keeping deployment straight and all that. And you really do need some way to sort of start collecting these things up and managing them as units and automatically customizing them with a C, customizing them either through templating with like Helm or through the customization YAML instructions that you have through Kustomize there, so you can run them in there. All right, let's make sure, let's see if we get some questions here. Yes, I will make sure that we get, that I share a copy of the PDF of the slides with the All Things Open 101 or Open Source 101 folks here, and they usually put them out on SlideShare, I think, so we'll do that. Let's see, any other questions? coming in? Have I completely, you know, as the old Far Side cartoon, excuse me, my brain is full here. This is kind of a lot to dump on you, but I hope that that's actually giving you some information. Any other questions?
Yeah, that's really helpful, I think. I don't see any more questions though, but yeah, people would want to maybe go through the slides again if you're going to share with.
Yeah,
Right.
absolutely. And I'll just mention, if you are not putting in a plug for this, but if you are interested, there is a hands-on Helm course I do in O'Reilly as well, if you want to learn more. Of course, there's lots of other resources out of there as well.